Okay, let's unpack this. Have you ever been in one of those chats, with another developer, maybe over coffee, maybe a code review,
Yeah, yeah.
and someone just like casually mentions that these huge tech companies, I mean, Google, Facebook, Microsoft, even Twitter back in the day, they actually store all their code
Huh,
in one single massive repository.
right.
And if you're like most devs, your first reaction is probably, well, it's almost physical, isn't it? That kind of confused look.
Yeah, the wait what face.
Exactly, that WTF expression. And then you think, maybe silently, maybe not so silently. Don't they know that's a terrible idea?
Mm-hmm.
Didn't we all spend years learning to break things down? Small repos, microservices, team autonomy.
Right. All the modern wisdom.
It feels like it just flies in the face of everything we preach about distributed development. It's almost legendary, this whole debate.
What's truly fascinating here, though, and often really counterintuitive,
Hmm.
is that despite those assumptions, the accepted wisdom about small repos,
Yeah.
the engineers at these places, they're not just aware of the alternatives. They've actively chosen this path. I mean, we're talking about places where, like, world-class experts in version control work. I think Junio Hamano, key Git guy,
Yeah.
he was at Google, right?
Okay.
And yet they don't just, tolerate a single huge monorepo. They actually prefer it. They advocate for it.
Huh.
So this deep dive, it isn't just about lines of code. It's about this really long, pretty compelling list of reasons why. Reasons that go deep into organizational efficiency, developer experience,
Right.
and how they manage complexity at just, well, an almost unimaginable scale. They didn't stumble into this. It was a considered, often pioneering engineering choice.
That's the crux of it, isn't it? It's easy to just dismiss it because it feels so wrong compared to what we usually do.
Mm-hmm.
But when the biggest names in tech are doing it, you kind of have to stop and ask why.
Exactly.
So our mission today really is to cut through all that noise, that confusion, peel back the layers.
Yeah, get past the myths.
We're going to explore those reasons, the compelling ones,
Yeah.
debunk some of those myths that everyone seems to believe, uncover the tooling, because that seems crucial.
Oh, absolutely critical.
The tooling that doesn't just make monorepos possible, but actually makes them, well, good, and ultimately help you, our listener, understand the real picture, the nuances.
Yeah, so you can make informed choices.
Exactly, for your own projects, your own teams, whether you're in a tiny startup or a big company or just trying to make your own workflow better. We're not telling you what to do,
Oh, definitely not.
but giving you the full story so you can decide what fits. Let's dive in. Okay, so first things first. Before we go any deeper, when we say monorepo, we really need to be clear about what we actually mean.
Good point. Because the term itself, it's loaded.
It really is. It often brings up these images of like a total mess, right? A disorganized nightmare. People picture this chaotic blob of code.
Just everything thrown together.
Yeah. But that's not what we're talking about today, not the well-managed ones anyway. The definition we're kind of leaning on, and it's one you see with modern tools like NX,
Mm-hmm.
is that a monorepo is a single repository containing multiple distinct projects with well-defined relationships.
And that last part is crucial.
Absolutely key. Yeah, with well-defined relationships.
It's not just code sitting next to each other.
Exactly. We're not talking about just code collocation, which is basically taking a bunch of unrelated stuff and dumping it in one Git repo. No structure, no thought about how things interact, no shared tooling.
Right, just a big messy folder, a glorified shared drive.
Totally. And it's also not what some people call a gargantua repo, which is kind of an interesting term.
Right.
That's when you have one truly massive application, but it lacks any real internal divisions or encapsulation. Just one big monolithic tangled thing.
Where everything knows about everything else. Spaghetti code at scale.
Pretty much. And that's actually the opposite of what a good monorepo aims for. A well-designed monorepo, in fact, is often the antithesis of monolithic.
Right. It's about structure inside.
It's about enabling internal organization, strong modularity, even within that single repo, but with a clear map of how those modules connect, interact, and importantly, what their boundaries are.
Mm-hmm, mm-hmm. And if we connect this to the bigger picture, the standard way most developers work today, that's usually the polyrepo approach.
Right, multiple repositories.
Exactly. Each team or each application, maybe even each big project, gets its own separate repo.
Which sounds logical.
It does. It has this really strong, obvious appeal up front because it promises, well, what sounds like total team autonomy.
Yeah, freedom.
The idea is super compelling, right? Individual teams operate independently. They choose their own libraries, their own framework versions, set their own deployment schedules without asking anyone, manage their own contributors. Minimal external dependencies, supposedly.
Sounds like the dream on paper. Move fast.
Totally. It seems like pure freedom, letting teams sprint ahead in their own little world without cross-team friction. It's intuitive, fits with microservices, feels modern.
But I sense a but coming.
Well, yeah. As we're about to see, that autonomy, while it sounds great, it can inadvertently create its own set of pretty significant, often hidden challenges,
Yeah.
especially as you scale up.
That's a really powerful point. This idea of autonomy, every team being its own speedboat. Sounds fantastic. But okay, if polyrepos offer all this freedom, what are these hidden costs? What's the catch that starts pushing organizations to rethink it? What's this polyrepo paradox? Because it sounds like freedom, but you're saying it leads to these unseen burdens.
You nailed it. That's the core paradox exactly. The promise of total autonomy often bumps right up against the reality of building complex, interconnected systems, which is, let's face it, what most modern software development is about, right?
Things have to talk to each other eventually.
Precisely. And in many polyrepo setups, especially as the organization grows, you start seeing these specific, often quite painful challenges pop up. And they really start to erode that initial promise of speed and agility.
Okay, like what?
Well, first, let's talk about cumbersome code sharing. This is arguably one of the biggest headaches.
Yeah, I can see that.
Imagine you write some critical utility function, maybe a shared data model or a common UI component, and dozens of other services or apps need it.
Okay.
In a polyrepo world, to really share that code properly, you almost always have to spin up another separate repository just for that shared piece.
Right, a dedicated library repo.
Exactly. And this introduces a, frankly, astonishing amount of overhead that has zero to do with writing the actual useful code. You're not just coding the logic anymore.
You're doing setup.
Loads of it. Setting up all the boilerplate tooling, configuring its own CI/CD environment,
Yeah.
continuous integration, continuous delivery, the automation stuff, managing who can commit to it, setting up a separate release process, then carefully setting up package publishing to some internal registry so other repos can even use it.
Wow, yeah, that's a lot just to share a function.
It's way more work than writing the function itself. It becomes a huge disincentive to actually share code properly. And honestly, the nightmare of just reconciling incompatible versions of third-party libraries
Oh God, dependency hell.
across dozens, maybe hundreds of independent repos, each with its own dependency tree. It can become this all-consuming battle for dev teams, just constantly fighting version conflicts, sapping productivity.
In there. It's awful.
And this leads right into the second point, significant code duplication.
Because sharing is too hard.
Precisely.
Yeah.
Because of that sheer hassle and overhead of setting up and maintaining those shared repos, teams often just take the path of least resistance, especially when deadlines loom.
Sure, copy paste is faster.
It is, initially. Instead of going through that whole laborious bureaucratic process to make a component truly shareable, they just duplicate common services, models, components across their own repos.
Like an auth service example.
Perfect example. Team A needs auth, Team B needs the same auth logic. Instead of building one shared library, they both just write their own version.
Saves time up front, maybe.
A little bit in that sprint.
Yeah.
But it's a huge waste of initial development effort, just reinventing the wheel.
Yeah.
And worse, it dramatically increases the long-term burden. Maintenance, security updates.
Right, a vulnerability in that duplicated auth code.
Nightmare. Imagine finding a critical bug and having to fix it, test it, deploy it in 10 different places, hoping you got them all. It's like playing whack-a-mole forever. Error-prone, costly.
Okay, that sounds bad. What else?
Then there's costly cross-repo changes. This is a major pain point, especially as systems mature.
Like a breaking change in a library.
Exactly. Or a critical bug fix in some foundational library. Or a breaking API change in a shared service that impacts dozens of downstream apps. In a polyrepo setup, making that change propagate is incredibly painful.
How so?
It's like trying to retile your kitchen, but each tile is in a different house, and you need permission from each owner just to lift one.
Okay, vivid analogy.
You have to set up separate dev environments for each affected repo, wrestle with totally disconnected revision histories, manually coordinate version updates, editing package.json files everywhere, and then orchestrate the releases across all of them, often in a specific painstaking order.
Sounds incredibly slow and risky.
It is. This logistical nightmare just grinds critical updates to a halt, delays innovation, and makes fixing urgent issues take way longer than it should. A simple logical change might take days, even weeks, to fully roll out.
Yikes. Oh,
Next up, inconsistent tooling. This one sneaks up on you.
what do you mean?
In a polyrepo world, each project, sometimes even each team, tends to develop its own distinct set of commands and scripts for basic stuff. Building, testing, serving, linting, deploying.
Oh, right. One uses NPM run build, another yarn build, another make.
Exactly. Or custom bash scripts, whatever. This inconsistency creates this huge mental overhead for developers.
Yeah, context switching is hard enough.
Totally. When a dev moves between projects or joins a new team or just needs to help out on another code base, they don't just learn new business logic. They have to learn a whole new set of commands, config quirks, conventions just to get started.
That cognitive load adds up. It's like a hidden tax.
It really is. Makes onboarding slower, cross-team contributions frustrating.
Okay, one more.
Yeah, and finally, all these little things kind of snowball into increased risk and complexity overall.
How so?
As systems grow, as you get more and more microservices and repos, that critical system knowledge gets incredibly fragmented, spread thinly across many teams and their repos.
Ah, so no one sees the whole picture.
Exactly. It can lead to these alarming situations where, honestly, sometimes no one truly knows how to build and deploy the entire system anymore. Holistically, the overall architecture becomes a black box.
That sounds dangerous.
It is. Tooling conflicts, configuration clashes become more common, harder to debug, bottlenecks appear, slowing down automated builds and deployments as the whole ecosystem gets more complex. It's not just tech debt, it's this growing knowledge gap, making the system brittle and resistant to change.
Wow, okay. Hearing all those polyrepo challenges laid out like that,
Mm-hmm.
it really clicks, doesn't it? You can totally see why some organizations, even with that initial skepticism, start looking for something different.
Mm-hmm.
It's like that first WTF reaction to a monorepo slowly starts to morph into, oh, hang on, that actually sounds pretty nice. Or even, wait, that's actually brilliant.
Yeah, the perception shifts.
You start seeing how it could solve those specific problems. So, if that's the polyrepo paradox, what's the flip side? What's the compelling upside that makes these huge tech companies not just put up with a monorepo, but actively embrace it, invest heavily in the tools to make it work? What's the aha moment?
That's a great question because, yeah, the advantages, once you really get them, they can be truly transformative. The reasons people prefer monorepos are pretty extensive. Insights from folks like Dan Liu, who's written about this, plus the practical experience from Google, Facebook, places like that. They really highlight these benefits.
Lay them on me.
All right, first off, simplified organization. This is really foundational.
Oh, so.
With a monorepo, you can organize your projects purely logically. You're not constrained by the version control system, forcing you to split things into separate repos just because.
Yeah.
You can structure your code base to perfectly mirror your business domains or your technical architecture.
Without worrying about Git repo overhead for every little piece.
Exactly. It reduces the administrative burden, the mental load of just managing all those project boundaries and relationships. And a fantastic side effect is easier navigation.
Ah, yeah.
Developers can just navigate between projects, shared libraries, no matter how nested, like it's all just one big networked file system. Using familiar commands like cd.
Instead of cloning multiple repos, opening multiple windows.
Right. That contrast is stark. Polyrepos often mean dealing with two levels of navigation, file system inside a project, and then this meta level of cloning or opening separate IDEs to jump between projects.
That makes sense.
And this leads directly to simplified development environment setup. This is a big one.
How does that work?
There's this powerful, almost implicit expectation. If I can CD into any project in this monorepo, then CD, or the modern equivalent like angx run mydaps.serve, it should just work.
Out of the box.
Well, the expectation that it should work drives the collective effort to build the tooling to make it work because it feels natural and it pays off immediately in developer efficiency.
Ah, so the structure encourages better tooling.
Precisely. It makes setting up local dev environments much faster and critically consistent across the whole organization. Imagine onboarding a new dev, clone one repo, run one install command, and boom, they have all the code, all the context they need.
Okay, that does sound pretty nice. Lowering the barrier to entry, easier context switching. But what about dependencies? That's always the big monster, right?
You are right to point straight at dependencies. That's often where the real pain lives in polyrepos. And this is where a monorepo can really shine. Simplified dependencies.
Okay, how?
Remember how managing cross-repo dependencies in all their different versions is such a nightmare?
Uh-huh. dependency hell.
With a monorepo, it becomes much, much easier to have one universal version number for all projects and shared libraries within that repo.
Hey, one version for everything internal?
Often, yes, or at least for closely related sets of libraries. The insight here is profound. Imagine never again debugging a version mismatch between two of your own internal libraries. That headache,
Right.
that constant battle, it could just vanish. Your entire internal codebase moves forward as one consistent unit.
How does that work in practice?
Because atomic cross-project commits are possible. You can make changes across multiple projects or libraries and commit them as a single, indivisible unit. It either all succeeds or all fails together.
Ah, so the repo is always consistent at any given commit.
Exactly. At commit #X, the whole repository is in a known working state, which means your build system files, make files, Bazel build files, whatever they don't need to specify version numbers for internal dependencies, they just point to a path within the
Oh,
monorepo.
interesting. No version specs internally.
Right. This eliminates a huge source of configuration errors and dependency resolution problems. It effectively sidesteps a lot of the complexity you see with tools like Maven or SBT, which get bogged down tracking intricate version graphs, or the mess of different dev environments that tools like UrbanV or Virtual Mstm try to manage in the polyrepo world.
Okay, that sounds powerful. Consistent state.
It really is. And this internal consistency has a massive impact on the enhanced tooling ecosystem.
Because tools have it easier.
Way easier. Tools only need to read files and understand dependencies based on their physical location in the repo. They don't need to deal with complex external interrepository relationships and versioning schemes.
Right, it's all just there.
Exactly. Christopher Van Arsdale from Google had this great description calling it Lego-like development.
Lego-like.
Yeah. He described building something new, like a web crawler or an RSS parser, or even a complex fault-tolerant data store.
Oh.
Sometimes it involved little more than adding a few lines of code. By leveraging this incredibly rich library of shared, high-quality, modular code blocks that were just readily available and perfectly compatible within the monorepo, that level of easy composition is way harder to achieve outside of monorepo because external dependencies always bring versioning friction.
So the monorepo enables this reuse culture.
Massively. It's no surprise that ex-Dual engineers, when they went to places like Facebook or Twitter, felt they had to build their own versions of Bazel, Google's build system, to get those same benefits.
Not just builds.
No way. The tooling advantages extend way beyond builds. Think powerful static analysis that runs seamlessly across project boundaries, highly effective cross-project integration testing, even incredibly efficient org-wide code search. It all gets easier when everything's in one place with consistent tooling.
So it simplifies the code structure, simplifies dependencies, simplifies tooling. What about making big changes? Refactoring across everything sounds, frankly, terrifying, even more so than in polyrepos, maybe.
But that's where another huge, perhaps the most compelling advantage comes in. Streamline cross-project changes and refactoring.
Really? How?
In a polyrepo world, refactoring some widely used API that's consumed by, say, thousands of internal projects, it's practically impossible. It's an organizational nightmare blocker.
Yeah, you'd never get it done.
But with a monorepo, you can perform an atomic refactoring.
Meaning?
Meaning you can modify an API and update all of its callers, potentially thousands of uses across hundreds of different projects, all in a single atomic commit.
Whoa. Okay, that is a game changer.
It really is. Think about it like this. Modern version control systems like Git, SVN, Mercurial, they solve the problem of atomic cross-file commits, right? Unlike older systems like CVS, monorepos solve the exact same problem, but at the cross-project level.
That's a great analogy.
David Turner, who worked on Twitter's monorepo migration, told this great story. He needed to update Project A, but A depended on B and B depended on C.
Okay, a dependency chain.
In the old polyrepo world, this meant waiting. Wait for C to release its fix, then wait for B to update to the new C and release its fix. Then finally David could update A and deploy it. Days, maybe weeks.
Ooh, yeah, the coordination tax.
But in the monorepo, his colleague fixed C, committed. David immediately fixed B, committed. Then fixed A, committed, all done.
Yep.
Deployed potentially within minutes or hours.
Wow, that's velocity.
Huge difference. And it has this beneficial side effect too. It forces dependees to update. When a core library changes, everyone using it has to adapt right away in that same commit, or shortly after. It prevents shared components from just stagnating because nobody wants to deal with the update hassle.
Keeps things current.
Exactly. Plus, tracking changes and debugging gets simpler. Tools like Git Bisect. They can operate seamlessly across the entire codebase to find the exact commit that broke something without needing complex meta tools or coordinating across repos. Now, there's a small nuance here. At Google's truly astronomical scale, even conceptually atomic changes might get split into multiple commits just for practical reasons, like making code reviews manageable. So that specific benefit might slightly diminish at the absolute extreme end of scale. But for most organizations, it's massive.
Okay, so organizational simplicity, easier dependencies, better tooling, atomic changes. Are there even broader benefits?
Oh yeah, Monorepos offer a whole suite of broader benefits for collaboration and standardization that really affect the whole engineering culture.
Like what?
You get easy visibility into the full code base. If you're working on microservice X, and it calls services Y and Z, you can instantly navigate to Y and Z's source code.
See how they work, debug issues?
Exactly. Quickly understand how they function, and crucially pinpoint if a bug is in your code, their code, or the interaction. It reduces finger pointings, speeds up debugging immensely.
Less blame game.
Hopefully. Code sharing becomes almost frictionless. Common data models, shared libraries, helper functions, they're easily accessible, discoverable, reduces duplication, saves engineering time.
Makes sense.
This naturally fosters improved collaboration. It breaks down those artificial barriers, the silos between teams. When all the code lives together, contributing to another team's component feels less like a major expedition and more like a normal refactoring task.
Lower friction.
Right. And it makes standardization much easier to enforce. You can apply consistent coding practices, linting rules, build configurations, even branching policies across all projects uniformly. Ensures a higher quality, more consistent code base overall.
One standard to rule them all.
Kind of. Discoverability is way better too.
Yeah.
A single view simplifies tracking status, doing code reviews, monitoring changes across the entire system. No need to hunt across dozens of repos.
Centralized view.
Yeah. Release management benefits because the knowledge of how to build, test, and deploy the entire system tends to be more centralized and understood, instead of being locked away within individual team silos, which is a huge risk if key people leave.
Good point. Bus factor.
And finally, for individual developers, developer mobility gets a huge boost. When there's a consistent way to build and test code across different technologies, even different languages, within the monorepo,
Yeah.
developers can jump in and contribute to other teams' applications much more confidently with less ramp-up time. It creates a more versatile, collaborative workforce. People can move around more easily, learn new parts of the system.
Okay, that is a really powerful case for the monorepos. You've laid out this vision of a significantly improved development process across the board. But let's get real here. No solution is perfect, right? There's no silver bullet.
Definitely not.
So what does this all mean when things inevitably get a little messy? Because monorepos, even with all those advantages, they must come with their own set of real challenges.
Oh, absolutely.
And maybe more importantly, they often spark these common fears, these misconceptions that we really need to tackle head on. Because those myths often stop teams from even thinking about it.
That's a crucial distinction, and you're absolutely right. It's vital to understand the genuine downsides, the real trade-offs, and then carefully separate those from the widespread myths that just aren't necessarily true, especially with modern tooling.
Okay, let's do that. What are the actual legitimate challenges people run into with monorepos?
All right, let's start there. First, the impact of common code changes. While atomic refactoring is amazing, the flip side is that a change to some widely used shared code can potentially affect a huge number of application components across the entire repo.
The blast radius.
Exactly. If those changes aren't managed super carefully, well-tested, communicated properly, they can lead to nasty merge conflicts, widespread CI failures, or subtle bugs popping up in unexpected places. The potential impact of one bad change can be significant.
Okay, makes sense. Needs discipline.
Loads of it. Second, deployment complexity. Now, setting up your local dev environment might be easier, but actually managing deployments for potentially hundreds, maybe thousands of different services from that one single repository, that can get incredibly complex if you don't have sophisticated tooling and processes in place.
Like coordinating rollouts.
Yeah, think about rolling out a feature that touches multiple microservices simultaneously, or managing blue-green deployments, or canary releases for lots of independent components that all live in the same repo. The orchestration required becomes a serious engineering challenge. Needs dedicated infrastructure.
Got it. Not simple.
Third, SCM system scaling. This is a big one for the giants. Standard source code management systems, Git, Mercurial, they weren't really designed for repos the size of Google's or Facebook's. Billions of lines of code, hundreds of thousands of commits.
They just choke.
Pretty much. Off-the-shelf Git or Mercurial would just grind to a halt. Basic stuff like git clone or git status would become unbearably slow. That's why these companies had to heavily patch and customize their SEMs. Facebook built Mononoke on Mercurial. Microsoft built VFS for Git, now GVFS for the Windows code base.
So you need serious, dedicated engineering just to keep the version control working at that scale.
Absolutely. Without that massive investment, it just doesn't work.
Okay, what else?
Fourth, repository bloat. This is a really common pain point, even for smaller monorepos.
Yeah.
The repo can get huge, not just lines of code, but the history, the .git folder itself.
Why? Binaries.
Often, yeah.
Huh.
People accidentally commit large binaries, images, build artifacts that shouldn't be there. I remember one DevOps person complaining about a 20 GB repo where the actual code was only 1 GB. The rest was just .git history bloat.
And that slows everything down.
Hugely. Cloning takes forever.
Yeah.
Fetching updates is slow. Even running git blame can become painful. Eats up local disk space too.
Right. Performance.
Which leads to the fifth point. Performance at scale in general. Even if you keep the .git folder clean in a really big monorepo, slow build times and long CI/CD waits are super common complaints if you haven't heavily optimized everything.
Like waiting ages for CI.
Yeah, waiting 30 minutes for a simple change to build and test, even if it only touched a tiny part. That kills developer productivity and morale. Needs constant attention.
Okay. What about open source?
Good question. Sixth, open source suitability. If you have an open source project living inside your company's giant monorepo, it can feel, well, onerous for external contributors.
Because they have to download the whole thing.
Exactly. Downloading this massive code base just to contribute a small fix to one part. It uses up bandwidth, disk space.
Yeah.
It can definitely discourage community contributions compared to a small focused repo.
Fair point.
Seventh, merge-triggered deployment inefficiency. This is a classic problem if your tooling isn't smart. Imagine every single merge to your main production branch triggers rebuilds and retests for all projects in the monorepo.
Even if they weren't affected at all.
Right. It wastes tons of CI/CD resources, creates queues, increases the risk of random failures in unrelated services, just unnecessary churn. Needs intelligent, affected detection.
Gotcha. Smart CI is key.
Eighth, feature branch management. While mainline development is often preferred, we can talk more about that if teams do use long-lived feature branches in a monorepo, it can get complicated.
How so?
Managing different features being developed simultaneously across many projects within the same branch. It can lead to non-production ready code accidentally getting committed or really gnarly, sprawling merge conflicts when trying to bring it all back together. Requires careful coordination.
Okay, last one.
And finally, ninth, granular user access. Traditional Git just doesn't have built-in support for fine-grained permissions at the folder level.
Meaning you can't easily restrict who can see or edit certain parts?
Not easily, no. This can be a challenge if you need specific teams or projects to have restricted read-write access to certain sensitive parts of the codebase for security or compliance reasons. There are workarounds, like pre-commit hooks or specialized SCM layers, but it's not a native Git feature.
Okay, that's a pretty solid list of potential headaches. But you mentioned misconceptions, too. Are there things people worry about that maybe aren't actually problems or at least are solvable? Because a lot of those sound like potential deal breakers, especially for teams without Google's resources.
Absolutely. And yes, there are several really deeply ingrained myths that definitely need debunking. These are often the first objections raised, but they don't really reflect how modern monorepos work, especially with the right tools and practices.
Okay, let's bust some myths. What's number one?
Misconception 1. Monorepos mean you have to use a single language or tool set for everything.
Ah, the polyglot problem.
Right. People think if it's all in one repo, everything has to be, say, Java, or everything has to use the same build tool. Reality, this is just not true anymore.
How do you solve it? Containers.
Exactly. You leverage modern deployment strategies and containerization. Each microservice, whether it's Python for your AI stuff, Java for APIs, Go for high-performance bits, Node.js for the front-end back-end, each one gets built into its own container image.
And deployed independently.
Precisely. Deployed as an individual unit. This lets diverse tech stacks coexist perfectly happily in the same monorepo. It also means you can test each containerized service independently. Polyglot development becomes a feature, not a bug.
Okay, myth busted. What's next?
Misconception 2. Monorepos automatically lead to tightly coupled code.
This is a big one. The monolith fear.
It really is. Maybe the most persistent myth. Reality. A monorepo doesn't inherently cause tight coupling. Coupling is fundamentally about architectural discipline and coding practices, not where the files live.
So it's on the developers.
Largely, yes. Teams must still follow microservice best practices. Build independent, loosely coupled units, communicate over clear boundaries, REST APIs, message queues, gRPC, whatever.
But isn't it easier to cheat in a monorepo? Just call a function directly.
It can be tempting, yes. The physical collocation might make it easier to break those patterns if discipline slips. A developer might be tempted to bypass an API and call some internal function in another module directly because, hey, the code is right there.
Right.
But the monorepo itself doesn't force that coupling. It's about how you manage the code, how you enforce those architectural boundaries. And actually, modern monorepo tools help with this.
How?
They have features like project constraints, dependency rules. You can define rules saying front-end apps cannot import database layers directly. Tools can enforce these rules, preventing unintended coupling. The collocation actually becomes an advantage for ensuring consistency and enforcing boundaries, not a risk for coupling if you use the tools right.
Interesting. Turning it into a strength. Okay, third myth.
Misconception 3. You can't update services independently in a microservice architecture if they're in a monorepo.
Yeah, people worry they're tied together. Deploy everything or nothing.
Reality. You absolutely can update services independently. This is purely a deployment strategy problem, not a repository structure problem.
How do you manage it?
You use the same advanced deployment strategies you'd use with microservices and polyrepos. Blue-green deployments, canary deployments. These are standard practice.
Explain those quickly.
Sure. Blue-green,
Mm-hmm.
you have two identical production environments, say blue and green. You deploy the new version of your service to the inactive one, say blue, while green keeps serving traffic. Test blue thoroughly. Then just switch the router to send traffic to blue. Green becomes the standby.
Okay. And canary?
Canary release.
Yeah.
You roll out the new version of your service to just a small subset of users. First the canaries. Monitor closely. If all looks good, gradually roll it out to everyone else.
And both let you update one service without touching others.
Exactly. Both strategies allow independent updates, thorough testing in production-like environments, and crucially, very fast rollbacks to the previous version if something goes wrong, all without impacting other services in your monorepo.
So the monorepo doesn't block deployment flexibility at all.
Not at all. It just means you need to implement these robust, standard microservice deployment strategies effectively at the individual service level.
Sure.
Your deployment pipeline targets a specific service within the monorepo, not the whole repo.
Okay, that separation between the real challenges and the common myths is super helpful. It really sounds like many of those traditional monorepo downsides, they can be tackled, maybe even eliminated. But here's the kicker, right? It's not just about deciding, hey, let's do a monorepo. It's about having the right tools.
Bingo. That's the absolute core truth.
You can't just chuck everything into one repo and, cross your fingers and hope for the best, can you?
No way. Without a really robust, intelligent toolkit, your monorepo will quickly degrade into that chaotic garganturepo mess we talked about earlier. It'll become unmanageable, slow, and just confirm everyone's worst fears.
But the good news is,
The good news is that modern monorepo tools have evolved dramatically. They're using really cutting-edge techniques, now distributed computing, advanced caching, intelligent graph analysis. They can handle repos of pretty much any size efficiently. They directly tackle those historical pain points like slow performance and repo bloat.
okay, so what are these crucial features? What makes these modern tools so effective? What are the game changers?
Great question. Let's break down some of the key features for monorepo success that these tools offer. First, fast local computation caching. This is fundamental for developer happiness and productivity.
Meaning don't rebuild stuff.
Exactly. It ensures you never rebuild, retest, or relint the exact same code twice on your own machine. You run a test, change a totally unrelated file, run the test again. The tool knows the results are still valid and just gives them back instantly from a local cache.
Saves a ton of waiting around.
Immense amounts of time and frustration. Second, local task orchestration. These tools are smart about running things. They understand the dependency graph, which project depends on which. They run tasks in the correct order, and crucially, they run independent tasks in parallel across all the projects in your monorepo. If A depends on B, B builds first. If C and D are independent, they build at the same time. Maximizes your local machine's cores. Third, distributed computation caching. This takes local caching and puts it on steroids for the whole team.
Sharing the cache.
Exactly. Cache artifacts build code, test results, lint reports get shared across different environments. CI agents, other developers' machines, even different branches can share the same remote cache.
So if CI builds something,
Your machine doesn't have to rebuild it. You just download the pre-built artifact from the shared cache. This prevents redundant work across the entire organization, drastically speeding up CI/CD pipelines. Huge win.
any downsides to sharing caches?
Well, you do need to think about security. Things like cache poisoning, where someone malicious might inject bad code into the shared cache, need careful consideration and mitigation. Robust security protocols are essential. Fourth, distributed task execution. This is for when you need serious speed, especially with huge code bases.
Running builds across multiple machines.
Yep, it lets you distribute commands, builds, tests across a cluster of machines, but it still feels like you're running it locally. Bazel is incredibly sophisticated here, scaling to billions of lines of code. Tools like Netkin's Pants also support this natively, and Lerno can use Netkin's Cloud for it.
So an hour-long build becomes...
Minutes, potentially. It gives you near-instant feedback even on massive changes. Fifth, transparent remote execution. This is a really cool feature, mostly seen in Bazel and Pants.
How is it different from distributed execution?
It can run any command remotely, not just predefined build or test tasks. Compile, test, lint, format, anything. The tool transparently packages up the inputs, sends them to a remote machine, runs the command, and streams the output back to your local terminal.
So your local machine feels like it has infinite power.
Pretty much. It completely abstracts away the remote infrastructure. Feels like your laptop suddenly gained hundreds of cores and terabytes of RAM. Sixth, detecting affected projects packages. This is absolutely critical for efficiency. Cannot stress this enough.
Only building what changed.
Exactly. And anything that depends on what changed. The tool intelligently figures out the minimal set of projects impacted by your specific code change. It ensures builds and tests run only for those projects, not the whole repo.
Saving massive amounts of CI time.
Huge savings. Next, Turbofo, Pants, Rush, Lage, Lerna all support this. They analyze the dependency graph, look at import statements, parse package.json files, etc. to figure out the impact. Seventh, understandable workspace analysis. Good tools figure out your project structure automatically.
Less manual configuration.
Way less. Tools like Netgex, Moon, Turborepo, Rush analyze manifest files, package.json, tsconfig.json, etc. to build the dependency graph. Pants goes even further, using static analysis across multiple languages. It means less boilerplate for you, and the dependency tracking is more accurate. Eighth, dependency graph visualization. Seeing is believing, right?
A map of the code base.
Yeah, interactive tools that let you visualize how projects and tasks depend on each other. Super helpful for understanding the architecture of a complex monorepo. Netgex, Moon, Turborepo have built-in visualizers. Bazel has query languages, helps you spot bottlenecks or weird dependencies. Ninth, manageable source code sharing. This sounds basic, but the tools make it easy.
Defining libraries within the repo.
Right. They let you clearly define distinct projects or libraries, making it simple to share common code in a structured way, ensuring things are organized into reusable modules. 10th, consistent tooling, using plugins to get a uniform experience.
Same commands everywhere.
Ideally, yes. Tools like Bazel, Gradle, Moon, NX, Pants use plugins. So whether you're in a Java backend, a Python script, or a TypeScript frontend, the command to build, test, or lint can often be the same. Reduces mental overhead, helps developers move between projects. 11th, code generation, scaffolding new stuff consistently.
Like next generation.
Exactly. Tools like Next, Moon, Pants have native support. They can create new apps, libraries, components with predefined structures, boilerplate code, configurations already set up, speeds up development, and ensures everyone follows the same standards from the start. And 12th, project constraints and visibility.
Yeah.
Enforcing architectural rules.
Like preventing bad imports.
Yep. Tools like Bazel, Moon, NX, Rush let you define explicit rules. Mark projects as private. Restrict imports. Front-end can import database code. Enforce layering. This lets you maintain architectural boundaries even though the code is collocated, fighting that tight coupling fear we talked about. Okay, so with those features in mind, let's quickly touch on some of the leading Monorepo tools in 2025 and who might use them. NX by NX Team. A real powerhouse, especially strong in the JavaScript, TypeScript world, React, Angular, Node, but super extensible via plugins to Go, Rust, Java, .NET, etc. Known for smart graph analysis, great caching, local and distributed, powerful code generation, ideal for full-stack JSTS apps, libraries, microservices at almost any scale, very integrated experience. Bazel by Google. The OG production grade, language agnostic. Its strengths are strict reproducibility, handling massive CI workloads, and top-tier multi-language support, Java, C++, Go, Python, TS. Steep learning curve, though, unique config. King for huge polyglot environments like Airbnb, Stripe, Dropbox, where correctness and scale are paramount. Turborepo by Vercel. High performance, laser-focused on JSTS. All about developer velocity. Blazing fast incremental builds, simple caching, remote and local, aware of frameworks like Next.js, React. Great choice for front-end heavy or full-stack JSTS teams wanting speed and simplicity with minimal setup. Pants by Pants Build Community. Scalable build system targeting multi-language monorepos, especially strong with Python, Go, Java, Scala. Known for precise dependency tracking via static analysis, automatic dependency inference, very concurrent execution. Ideal for large mixed language codebases where granularity and performance across different stacks are key. Gradle by Gradle Inc. Very flexible build tool, shines in multi-project builds, especially in the JVM world. Java, Kotlin, Groovy. Supports other languages via plugins. Offers incremental parallel builds, declarative scripts. Good fit for enterprises already using Gradle or with a heavy JVM focus. Lerna. More of a historical tool for managing JS projects with multiple packages. Still used, but nowadays often relies on Nexus underneath for caching and task running, making it a powerful combo for JS Rush by Microsoft. Tailored for very large JSTS monorepos with many teams. Focuses on things like shared package.json configs and using rig packages, reusable bundles of tooling configuration to enforce consistency across hundreds or thousands of projects. Moon by Monorepo. A newer player, task runner, and monorepo tool for the web ecosystem. Offers native code generation, good project boundary support, focus on developer experience. And beyond these core build management tools, remember those supporting tools like Aviator. They don't replace NetX or Bazel, but they integrate with them to fix workflow bottlenecks.
Like the pull request process.
Exactly. Things like intelligent merge queues, testing merges before they hit the main branch so it never breaks. Native support for stacked PRs, where one change depends on another, still in review. Context-aware code reviews. These tools tackle the human collaboration friction points, boosting throughput even further. #Tech6. Best practices for thriving in a monorepo environment.
That whole section on the toolkit really drives home just how specialized and, well, engineered these monorepo environments need to be, especially when they get big. It's so clear that success isn't just about flipping a switch to monorepo mode. It's fundamentally about how you manage it, how you evolve it, and the practices your developers actually follow day to day.
Couldn't agree more.
And this is where it gets really interesting, right? Moving from the what and why to the practical, actionable how. Because, like you said, even the best tools can't save you from chaos if you don't have solid best practices in place.
Precisely. Success in a monorepo is absolutely not accidental. It's the direct result of deliberate strategy, ongoing investment, both time and resources, and consistent adherence to a set of well-understood best practices. If you ignore these, you'll quickly run headlong into the very problems the monorepo was supposed to solve.
Okay, so what are the key practices for making a monorepo thrive?
All right, first and foremost, structured organization. This is non-negotiable. You must maintain a clear logical structure right from the beginning. Actively fight the urge to just throw everything in randomly.
Avoid the dumping ground scenario.
Exactly. As some wise developers have pointed out, having completely unrelated code in the same repo is pointless if it doesn't offer any benefits. You need a plan. Think about organizing by business domains, maybe technical boundaries like an apps folder for deployable things and a libs folder for shared code. Or organize by team ownership or application types.
Make it intuitive.
Yeah, create clear, intuitive divisions. This makes navigation easier, discoverability better, and understanding project boundaries much simpler for everyone. Next, efficient CI/CD integration. This is absolutely critical, and it has to be intelligent.
To avoid building the world on every commit.
That's the main goal. A common fear and a real pain point in badly set up monorepos is that tiny change triggering full pipelines everywhere. So to fight that inefficiency, you need intelligent build triggering. Your CI/CD pipelines must figure out what actually changed and only run tests, builds, versioning, releases for those projects, and anything that depends on them. Tools like Next and Turborepo are great at this, analyzing the graph to find the minimal work needed. Path and branch filters. Use the features in your CI system, GitHub Actions, GitLab CI, Jenkins, whatever, to track our workflows only when files in specific directories change, maybe combined with filters for specific branches like main or release branches. Parallel job execution. Design your pipelines for concurrency. If you have 20 independent services, don't build them one after another. Run them all at once on separate CI agents. Slashes pipeline time. Caching strategies. Be aggressive with caching. Cache everything you can, compiled code, test results, downloaded dependencies at multiple levels, local dev machines, CI agents, and ideally a shared remote cache for the whole org. Avoid redundant work. Automated dependency analysis. Your CI system needs to understand the project graph automatically to trigger only the necessary tasks. The Monorepo tool often provides commands for this, nx-affected.build, etc. Mainline development. Consider it. Think about adopting this. All changes merge directly to the main branch frequently, in small increments, followed immediately by automated testing and deployment. This avoids complex merge conflicts from long-lived branches. But, big caveat, requires a super strong testing culture, robust automated rollbacks, and discipline around small commits. Security scanning. Integrate security scans right into the merge process. Scan code and dependencies before they hit main. Much more effective than finding vulnerabilities weeks later. Comprehensive CI/CD. Go beyond just build and test. Include performance testing, automated code review checks, linters, formatters, dependency vulnerability scanning, maybe even automated environment provisioning as part of your standard pipeline. Effective dependency management is another absolute pillar. You need a centralized strategy, centralized version control. Have one place to define the versions of your shared external dependencies. Maybe your rootpackage.json in JS land, or a gradlibs.versions.toml for Gradle projects. Avoid defining versions scattershot across projects. Workspace management tools. Rely on your Monorepo tool, NX, Yarn workspaces, PNPM workspaces, etc., to handle the relationships between your internal packages, and ensure they use compatible versions of external dependencies. They resolve the complexities. Implement version policies. Maybe enforce rules automatically, like no two projects can depend on conflicting major versions of library X. Use tooling checks and PRs. Shared code management. Use the workspace tools and define clear APIs for your shared internal libraries. Discourage projects from reaching into the internals of other projects. Enforce communication through defined interfaces. For performance optimization, you have to be proactive, especially about repo size and build speed. Repository maintenance. Don't let the .git history get out of control. Regularly clean up large histories using tools like git-filter repo or similar techniques, especially if big binaries or junk files got committed accidentally in the past. This can dramatically shrink repo size and speed up clones and other Git operations. Build optimization. Beyond smart caching, seriously consider investing in distributed build systems like Nextcloud, Bazel's remote execution, and potentially cloud-based build infrastructure. Distributing the build load across many machines is key to keeping builds fast as the code base grows. And then there's the tricky topic of versioning best practices, specifically for the libraries you publish from your Monorepo. This gets complex fast and is often misunderstood. Let's look at the options. Option 1. Single library versioning. Simplest case. You have just one library in the repo or maybe multiple totally unrelated libraries. Each gets its own independent version. Fine. But if they're unrelated, why are they in the same Monorepo? Kind of misses the point. Option 2. Individual versions per library in Monorepo. This seems logical at first, but for interconnect libraries published from the Monorepo, this is usually the option to avoid. Why? It creates chaos for your users. Which version of @MyOrgi controls works with which version of @MyOrgi data grid? Testing becomes a nightmare, which combinations are valid. And it often leads to duplicate code problems in the consuming application. If users accidentally install incompatible versions that pull in different versions of some underlying shared dependency, you're basically exporting your internal dependency hell to your users. Option 3. One common version for all libraries in Monorepo. This is much simpler for users in testing. All related libraries share the same version number. For example, everything is @MyOrg at 2.0.0. A change to any library bumps the common version. Challenges. Well, a tiny fix in one library forces a version bump for all libraries, even unaffected ones. It also requires tooling that can handle these universal updates correctly, and users might still get weird states if your internal libraries depend on each other using flexible version ranges, like 1.2.3, instead of exact pins, allowing subtle divergences. Option 4, common version plus pinned internal dependencies plus utility tools. This is often seen as the most robust and practical approach for complex, interconnected libraries. All related libraries share one common version, GV 5.5.0. Crucially, when these libraries depend on each other within the Monorepo, those internal dependencies are pinned to exact versions. For example, dependency @MyOrgitils, 5.5.0, not 5.5.0. This prevents users from accidentally getting mismatched internal versions. Then, to handle updates smoothly, you develop utility tools. Maybe a CLI command like myorg update all 5.6.0 that help users update all your libraries and ensure the internal pin versions are correct, preventing discrepancies and duplicates. It gives consistency and control. Now, for managing external dependencies like React, Lodash, etc., within your monorepo libraries that you publish, avoid pinning exact versions for major widely used libraries like React 17.0.2. This causes huge problems for your users who might need a different patch version or have other libraries requiring a slightly different version. Use peer dependencies or flexible ranges, 17.0 or 17.19. Be cautious even with pinning major versions, React 17.0. Only do this for libraries with super stable APIs, as it still forces your users onto that major version. Pin strategically. Only pin external dependencies to exact versions when you know there's a specific bug, security issue, or incompatibility with newer versions that you need to avoid. Otherwise, allow reasonable flexibility using ranges. 4. And finally, sometimes it makes sense to segregate versioning for certain libraries even if they live in the monorepo.
When would you do that?
Maybe for a very general purpose, foundational libraries like a company-wide logger or a core utility package, especially if they're heavily reused by projects outside the main monorepo codebase, or have very low interdependency with the rest of the monorepo's libraries. Giving them independent versioning can avoid forcing unnecessary version bumps on the main group and prevent duplicate versions if external consumers are on different release cycles. So your main product libraries might be at v5.5.0, but a core logger could be independently versioned at v2.1 or 0.
Okay, that was incredibly thorough.
Yeah.
We've gone from the philosophical why of monorepos through the nuts and bolts of tooling right down to the nitty-gritty of versioning practices. So putting it all together, what does this mean for you, the listener, and your team? How do you actually decide if a monorepo is the right way to go or if sticking with polyrepos makes more sense? This is really where the rubber meets the road, isn't it?
It absolutely is. This is the million-dollar question, right?
Yeah.
And the answer, honestly, like with so many things in software architecture, it depends. It's nuanced. There's no single right answer for everyone. But there are definitely key factors you should weigh up to make an informed choice, one that actually benefits your specific situation.
Okay, what should people be thinking about?
First, really assess your team's culture. Seriously. Is your team environment a good fit for the kind of deep collaboration, shared ownership, and cross-team visibility that a monorepo naturally encourages, almost requires?
Does it need a certain mindset?
I think so.
Uh-huh.
A monorepo really thrives where teams are willing and able to work together closely, contribute across perceived boundaries, feel comfortable looking at and understanding each other's code. Is there a culture of shared ownership where fixing something in another team's library is seen as normal teamwork, not stepping on toes? Or are your teams very siloed, preferring strict autonomy, minimal interaction? If it's the latter, a monorepo might just feel like constant friction.
Good point. Culture match is key.
Mm.
What else?
Second, and just as important, honestly assess your team's discipline. Can they, realistically, refrain from creating tightly coupled code, even when the temptation is right there? Because all the code is visible and accessible.
The easy path temptation.
Exactly. Can they consistently enforce good microservice practices, independent units, clear APIs, even when things are collocated? This discipline is absolutely non-negotiable. And like we said, it can and should be enforced with tooling project constraints, dependency rules, branch policies, deployment permissions tied to directories. But the will to maintain that discipline has to be there. Without it, the monorepo risks turning into that monolithic mess, and you lose all the benefits.
Discipline and tooling working together.
Precisely. You also need to consider the trade-offs very carefully and honestly. Monorepos offer those undeniable pluses: easier code sharing, those powerful atomic refactors, unified tooling, consistent standards, potentially leading to faster development cycles, fewer integration headaches. But those benefits require real investment, upfront and ongoing.
Yeah.
Investment in infrastructure, in the developer experience, DX, in maintaining those disciplined workflows. It's not a free lunch. You're essentially trading one set of problems, like polyrepo coordination overhead, for another set, like needing robust tooling and strict discipline. Hopefully the new set is more manageable for you.
So when is the value proposition strongest?
The value proposition of a monorepo really shines when code sharing is central to your workflow. If your apps constantly rely on shared internal libraries, models, components, the benefits are huge. And also when you really value that local dev easy experience.
The one clone, one install, run everything idea.
Yeah, that ease of setup, the consistency, the ability to run and test interconnected services locally from the main branch with minimal fuss, that's a massive motivator for many organizations. It just simplifies the day-to-day development loop.
Okay, but what's the big warning label?
The big cautionary side is this. Real success, especially as you scale, requires substantial engineering investment in people to keep the tools working and support them.
Dedicated roles. Build engineers, infra teams.
Often, yes. Or at least significant time allocated from existing teams. You need people focused on maintaining the build system, the CI/CD pipelines, the caching infrastructure, the developer tooling. If you don't have those resources, or if you just expect off-the-shelf tools to work perfectly without any customization or maintenance, well then developers are going to be frustrated because those tools will not be able to scale or adapt to your specific needs.
It needs ownership.
Absolutely. As someone cleverly put it, Monorepos are as good as the devs behind them. A great disciplined team with strong tooling and support can make it amazing. A less disciplined team without that investment can turn it into a giant headache, a huge liability.
So ultimately, it depends.
It really does. Context is everything.
Yeah.
Team size, project complexity, technical maturity, organizational culture. But here's the optimistic note, the path forward. Modern tooling has genuinely lowered the barrier to entry significantly.
Made it more accessible.
Yeah. These lightweight stacks, combined with really smart caching and intelligent graph analysis from tools like Next, Turborepo, Pants, they mitigate so many of the traditional Monorepo pain points. They make the approach much more viable, performant, and powerful for a much wider range of organizations now, not just the Googles and Facebooks. You can get many of the benefits without necessarily needing a giant dedicated tooling team, especially for small to medium setups. It allows for approaches that kind of blend the best of both worlds, bringing that enterprise-grade efficiency within reach for more teams. Hashtag Harshwood Trey.
Wow, okay. What a journey we've been on today. We started with that, maybe familiar WTF is a monorepo, and why would anyone do that?
Yeah.
Feeling. And we've explored these really intricate reasons why some of the most advanced engineering teams out there don't just use them, they swear by them. We've hit the big advantages: simplified organization, atomic changes, the boosted tooling ecosystem, easier collaboration.
Right, the compelling upsides.
And crucially, we also stared the challenges right in the face. The scaling issues, the need for discipline, the deployment complexity, while also busting some of those persistent myths that often cloud the discussion.
Separating fact from fiction.
Exactly. And what's become crystal clear throughout this is that the specialized intelligent tooling, it isn't just a nice bonus, it's absolutely essential. It's the key that unlocks the benefits and stops the monorepo from becoming a burden.
Couldn't have said it better. The tools are fundamental. Which, raises an important final question, maybe something for you, the listener, to ponder.
Yeah.
This shift towards potentially adopting a monorepo or even just adopting monorepo principles, it isn't just a technical architecture decision, is it? It's often a really profound perception shift. It fundamentally changes how an organization thinks about its code, how it thinks about collaboration, about efficiency.
It's a cultural shift, too.
It really is. It demands the continuous investment, not just in the tools themselves, but in the discipline, the practices, the culture of everyone involved, from the newest dev to senior leadership.
Yeah.
But, and this is the hopeful part, with the right tools, the right practices, and that essential cultural buy-in and discipline, it can empower a level of development velocity, consistency, and organizational cohesion that's just incredibly hard to match otherwise. It forces you, in a good way, to think about your entire code base, your entire product portfolio, more holistically, as one single evolving entity.
That is a powerful thought to end on, a holistic view. So as you, our listener, reflect on everything we've dived into today, maybe take a moment. Think about your own development workflow, your own team's challenges. Are there specific pain points in your current setup? Maybe around dependency management. Maybe cross-team collaboration is clunky. Maybe your CI/CD feels slow and brittle.
Could a monorepo, implemented thoughtfully with modern tools, actually address some of those?
Or maybe, even if you stick with polyrepos, could understanding these monorepo principles that focus on tooling, consistency, dependency management, affected computation, help you improve your existing strategy?
Yeah.
Help you mitigate some of those polyrepo paradoxes without needing a full migration?
Yeah, the principles themselves are valuable everywhere.
Absolutely. The ideas we talked about today, they're applicable no matter what your repo structure looks like right now. Well, thank you so much for joining us on this really deep exploration.
My pleasure. It was a great discussion.
And we look forward to seeing you on the next deep dive.